Consider the functions f and g, where f is 3 cosine 2x and g is 4 minus 11 cosine x. Find the x-coordinates of the points of intersection of these two graphs. We can make the two functions equal to each other to find these 2 points. We can rewrite cosine 2x using a double angle identity. We will use the identity that only involves cosine. So this would be 2 cosine squared x minus 1. We can then expand the parentheses and we're left with a quadratic that can actually be factored. We can split apart the middle term 11 cosine x into 14 cosine x and minus 3 cosine x. After factoring, we're left with 2 cosine x minus 1 times 3 cosine x plus 7. This will be equal to 0 when either one of the factors is 0. So let's first make the first term equal to 0. This would give us cosine x equals 1/2. Cosine is 1/2 when x is pi over 3 and 5 pi over 3. We can also make the second factor equal to 0. Although this will result in extraneous solutions because cosine is never less than minus 1. Part B asks to find the area of the shaded region. We can represent this as a definite integral of the difference between functions g and f, with the limits being the intersection points of the two functions. We can now integrate and we get 4x minus 11 sine x minus 3 over 2 cosine 2x. We can then use a fundamental theorem of calculus and substitute the upper and lower boundaries into x and subtract the two values. So the value of this integral is 16 pi over 3 plus 25 square root of 3 over 2. At the points A and B on the graph, the gradients of the two graphs are equal. We need to determine the coordinates of A on the graph of G. The values of the gradients can be represented using the derivative. We can find the derivative of both f and g, and then make the two functions, the two derivative functions, equal to each other and find the points where they are equal. We can use a double angle identity to rewrite sine 2x as 2 sine x cosine x. Rewriting it like this will allow us to cancel out the sine x from both sides and just leave cosine x. We can now substitute this value for cosine into the function g to get the y value. So then the y value is 169 over 12. So that's it for this video. Thank you for watching, and I hope I helped you with this question. Please like and subscribe. Bye!